Me again, second half of chapter 5. I think I'd like to do some examples and then back over some of the stuff I've talked about here, and I think it'll become more clear. A lot of this stuff is theoretical background, and it's important. It is. It should be in the back of your head, but honestly, the actual process of doing a t-test is you look at a number, you compare it to a table, and you're done. All right, so I want to do some of that. All right, so let's actually conduct some t-tests here, and let me show you the table again. There's three things you want to get clear in your head on the table. First is, am I doing a one-sided or a two-sided test? As you can see there, the one-sided is across the top, right underneath the words level of significance. Two-sided after that. And then, am I looking to see if it's significant at the 10% level, the 5% level, 2.5, 1, half? And really, well, I'll tell you more about that later. Right. And then on the two-sided, quite honestly, I told you that we wouldn't do what's right underneath there, the very first one on two-sided, the 20%. And the only reason it's there is because it's the same thing as a one-sided 10%. But anyway, that's not really important, John. On the two-sided test, 20%, 10%, 5, 2, and 1. All right, so first thing you have to decide is, am I doing a one-sided test or a two-sided test? Did I hypothesize a sign for this variable? If you did, it's a one-sided test, period. I'm going to say it again, extremely important. If you hypothesized a sign for this variable, then it is a one-sided test, not a two-sided test, and you will be surprised how many professional economists screw that up. All right, don't you be one of them. So, first thing is, am I doing one-sided or two-sided? Second question is, what level of significance am I shooting for here? What's going to be my standard? And we're going to vary that on different homework problems just to give you practice. Let's say one-sided 5%. All right. So we're going to clearly use this. Let's see if I can get my hand in the right spot. This column right here. One-sided 5% is that column. Now, the last piece of information I need is the degrees of freedom. Because if you'll notice, the t-values for one-sided 10% are not all this. I'm sorry, one-sided 5% are not all the same. The first one is 6.314, then 2.92, and so on, as you get more and more degrees of freedom. There's a really easy, intuitive reason for why the numbers get smaller as you have more degrees of freedom. But let's first do the degrees of freedom. And I mentioned this in an earlier chapter, don't remember which one it was. Degrees of freedom. Degrees of freedom are equal to, oops, n minus k minus 1. Number observations, number independent variables, and then that's just for the mean. All right. Let's say you have 50 observations, and you are doing this class thing again. You are using just hours of study as your only explanatory variable. Your degrees of freedom are 48. Now, the idea of degrees of freedom, and this is a really hard one to explain intuitively, but the idea of degrees of freedom is, as I told you in an earlier episode, is the number of independent pieces of information. Okay, you can see that as you have more and more observations, degrees of freedom go up. It's always better to have more observations, right? So that's the first thing. Now, this number over here, you always do -1 because the idea is, let's say we have a population. Let's say the average grade in class was a 75. And we've got 10 students we're thinking about here, about what their grades might have been. Well, for the first 9 students, we could put in whatever frickin' number we want, right? I mean, so long, obviously with a grade, we're limited to it probably being 0 to 100, but let's say no. Let's say, hey, the test could be out of 1,000,000, right? So if we know the average grade is 75, and we know there's 10 students, students 1 to 9, there could be any value we wanted in there. But if we know the average is 75, student number 10 better bring us to 75, right? So these numbers up here can vary wildly as long as the last one you're not free to do whatever you want with it. The last one must contribute to making the average 75. Now, that's why that one's there. This one, we're also placing an additional constraint. Not only did the first 9 can be anything, but the 10th has to be something that then contributes to the average being 75, but also we're asking it to be related to hours of study. Or we're asking it to be related to hours of study and cups of coffee, which would make this number 2. Or hours of study, cups of coffee, and absences. The more we ask the data to explain to us, the more constrained the data set becomes, the more difficult it is for that data set to explain so much. You want me to explain not only how people did on the exam based on how many hours of study they have, but to also tell you how that relates to how many cups of coffee? And think about this. The computer is being forced to take into account that to sort of hold constant one of those while it's determining the fluctuations caused by the other variable. We'll get into that as well. But anyway, so that's the degrees of freedom, all right? And it's a very difficult concept. I'm not sure I totally understand exactly why it works this way, but the idea is that the more you ask the data to do, the more difficult it is for that same data set to come up with the right answer. So, what's particularly important to us, 1 is 1, right? But K is going to vary by how many explanatory variables we put in, and N is going to vary by how many observations we can get. Now, think about this. We're trying to come up with the critical t-value, right? We want to come up with the critical t-value for a one-sided test. That's what I said a minute ago. 5% level of significance. And we want the critical t-value for that. Let's say we're talking about the tossing the coin thing again. How significant is it that you got 60% heads when you tossed the coin 10 times? It's not that big a deal, right? 10 times you could easily end up with 6 heads and 4 tails if you tossed it 10 times. What about 100? Well, I guess it's possible you could get 60 and 40. What about 1,000? What about 1,000,000? At 1,000,000 tosses, 60% is much more significant than it is at 10 tosses. At 1,000,000 tosses, 60% heads is kind of a big freaking deal. This is a real pattern here. But with only 10 tosses, well, yeah, one could easily end up with 6 heads and 4 tails with just 10 tosses. But with 10,000,000 tosses? Now I'm starting to think that it's unfairly weighted. So the bigger N is, the easier it's going to be to prove your case. And that is why, my friends, everywhere on this table, the critical t-values get smaller as you have more observations. Or I should say more degrees of freedom, but obviously those are going to be highly correlated. That as you get more degrees of freedom, so the critical t-values get smaller and smaller and smaller. And that is because it is even with the same percentage, even with the same distance away from the solid black line, if it's for over more observations, that's more confidence, all right? And if it's more confidence, then, well, I don't need as big a percentage of, I don't need as big a percentage of heads to convince me at 10,000,000 tosses than I do at 10 tosses. At 10 tosses, I better get 8 or 9 heads, at least, before I'm going to say that's an unfairly weighted coin. But at 10,000,000 tosses, I don't need 80 or 90%. Probably 60% is sufficient to say, oh no, statistically speaking, that's a heck of a lot of heads, right? So, the more degrees of freedom you have, the smaller the critical t-value. And remember, you want your t to be bigger than the critical t. Let's go back to this. I think I have it here. Diagram right here. Yeah, here it is. here's a one-sided test. And the part that's cut off over there, ignore the numbers that are on there. I'm not sure what they were using this for at the time. I don't remember. But the critical t-value, well, hell, let me just draw it. I don't want to use that one. All right. There's your 10% cutoff or your 5% cutoff or whatever. And it's cut off by a critical t-value. But what that number is varies significantly depending on degrees of freedom. Hey, let me just jot a couple of them down. Let me jot down a couple of critical t-values for a one-sided test, 10% level of significance. All right. If I only had df, yeah, let me little table here. df/tc. If I had 1 degree of freedom, the critical t-value is 3.078. So that number becomes 3.078. Let me make sure I picked up the wrong number. Right number, 10%, one-sided. Yeah, that's right. With 1 degree of freedom, it's 3.078. So your t-value that you get when it's spat out on the computer, remember before it was, there was your parameter estimate, there was your standard error, so your t-score was right there. Or 2. I did another example is 2. If that were the case, and by the way, so a lot of times you can look at the number, you're like, I don't even have to look it up. I mean, a 5 is almost always going to be significant, right? But the 2 is not going to make it here, all right? So you're like, well, crap. Let me get some more data, all right? So now let's say you have degrees of freedom of, oh shucks, I don't even need to go very far, but let's say 10. So you got yourself 9 more observations. At 10, the critical t-value becomes 1.372. Suddenly, both of them are significant. Not only is 5 bigger than 1.372, but 2 is also bigger than 1.372. So notice that even with this lower t-score, the computer is now saying, the statistical tables are now saying, oh no, that's actually a significant number. That now, the parameter estimate of 10, you do reject the null hypothesis that this is an insignificant number. And so the more degrees of freedom you have, the better. All right. Had it been the absences, let me erase the whole thing. Do it again. Had it been for absences, then you would have expected a negative number. %, critical t-value, negative critical t-value. Because here's the point I'm trying to make here. All of these numbers are positive. So what you do when you're testing something you expect to be negative, you just use a negative value here. So let's see, let me do the same thing here, degrees of freedom versus the critical t-value, and I'll do 5 and 15, and we'll see what we get here. 10% level 5, 1.476, and 15 is 1.341. Okay. What this is saying is that the critical t-value, if you're looking for a 10% level, one-sided, negative in particular, with 5 degrees of freedom, that's negative 1.476. So if the t-value that you got on your regression was to the left, or in other words, smaller than negative 1.476, then you could reject the null hypothesis, which is a good thing. And if not, then, if it's equal, you don't reject the null hypothesis, which sucks. And then if you had 15 degrees of freedom, pardon me, that number will be negative 1.341. And then if it's a two-sided test, do 10% level again. TC, negative TC, all right? So 10% level again, which means we cut off what? Man, this sucks not being able to actually directly talk to you because it's so much more fun and so much more helpful for you when it's not on a video, but it's in real life. But anyway, I would normally now be saying to you, so if we have 10% level, how much are we cutting off right here to the right? And you would say, 5%. And I would say, that's right. With a two-sided test, rather than cutting 10% off to the right, you cut 5% off on this side and 5% off on the other side, right? So you do some off of each side. And then when you look up the table, here, let me do this again. Degrees of freedom and critical t-value for a two-sided test, 10% level of significance. And I don't know, let's do 20 and 30. Two-sided test, 10% level, 20 is going to be 1.725 and 30 is going to be 1.697. So, for a two-sided test, 10% level of significance and 20 degrees of freedom, 1.725 and negative 1.725. It's the exact same number, just the negative on the, it's symmetrical. For 30 degrees of freedom, 1.697, negative 1.697, all right? Now notice something here. Notice that the critical t-value for a two-sided test at the 10% level is also the exact same number as a one-sided test at the 5% level. Let me say that again. The critical, in fact, let me perhaps even write it down. TC for two-sided at 10% level is same as TC for one-sided at 5% level. All right, so the critical t-values for a two-sided test at the 10% level are going to be the exact same ones you would have had for a one-sided test at the 5% level. And now look back at the table again. Notice that on the two-sided 10% level, look what's right above it, one-sided 5%. Those are the same numbers. So the numbers you would use for a one-sided 5% are the same as the numbers you would use for a two-sided 10%, right? Great stuff, great stuff. Okay, now I think I'm getting close to wanting to show you some examples here. Let me see where I am. There's page 24, page 25. I already told you this because I skipped ahead and did that next. Okay. Yeah, all right. Now let's do some examples, and then that's the end of this chapter, isn't it? Yeah, it is the end of this chapter, all right. Let's do some examples, because you're going to be doing this all the time, all right? There's going to be the most common thing you're going to do is t-tests all the way through the end of the semester, and honestly, when you're doing this kind of work, that's what you're sitting there waiting to see. The paper that I wrote on Keynes's investment function, I didn't know it was going to work or not. And so when I got done and got the t-scores that I did, I was like, oh my God, I didn't even have to look them up. I'll look them up here for you in a minute to tell you what they were, but I don't remember offhand, but I didn't even have to look up the table. The t-scores were so high, and I was like, yes, it's exactly what I wanted. All right, let's do some examples. Let's do in fact, let's do it this way. Grade equals 15 plus 7 times hours. Plus 2 times absences and minus 3 times coffee. Okay. So let's say you ran a regression on how students do on exams. And the regression you ran was grade as a function of, and I'm going to put a hat over this so I don't have to put the residual at the end. Grade as a function of hours of study, number of absences, and cups of coffee. And these were your hypotheses. You hypothesized that hours was going to have a positive impact, that absences was going to have a negative impact, that it would lower your grade as you have more absences. And on coffee, you weren't sure. You weren't sure what you were going to get. And let's say that your total number of observations, let me make sure I'm picking out something that's going to give us a number that's actually on the table. I'll go in there. All right. Let's do 20. Observations, all right? So first of all, how many degrees of freedom is 20 observations? Remember, and as I said, in the T table in the back of the book, it will remind you that this is how it works. A really great book. It's n minus k minus 1. The computer does it for you. But anyway, n minus k minus 1. So we got 20 minus 1, 2, 3 minus 1, 26 degrees of freedom. Now, let me tell you that, first of all, we're going to be doing a one-sided test on this variable, a one-sided test on this variable, and a two-sided test on this variable. And let's pick the 5% level for all three just for something to do, okay? So what we want to know now is, let's see, and I'm trying to decide if I want to go ahead and, well, no, not yet. All right. Immediately, I know I got a problem. Immediately, I haven't even put any t-scores down, right? I don't have any t-scores. I already know that one of them is not going to pass. And it's this one. I hypothesized a negative sign. Hey, that's a good idea, John. Let's do this. Yeah. Let me do this. That was a terrible one, sorry. Dang, I'm almost out of room. Let me put one over here. Okay, that's going to be my two-sided. This is going to be my one-sided. Hey, let me do it in the same color as I was doing for those tests over there. Here's my two-sided. This will be my one-sided negative and my one-sided positive. Okay, now let's look up the critical t-values. And for a one-sided positive test, 26 degrees of freedom, and I wanted 5%, right? Let's put this somewhere. 5% level of significance. Yeah. 5% level, one-sided, and I'm going to trust you to get out your book and look and in fact, I'm going to wait a second. Pause the video. And look up and see which one is 5% one-sided, 26 degrees of freedom. It is 1.706. Let me double check. 5%, 26 degrees of freedom, one-sided. 1.706. That's right. That also tells me what it is down here, right? Negative 1.706. Now, what is it for a two-sided test? 5%, two-sided, 26, 2.056. 2.056, negative 2.056. Let me double check I get that right. 26 degrees of freedom, 5%. Yeah, that's right, 2.056. All right, so there's my critical t-values. Now what you're going to do is, for these two, notice that on this one here, on the negative one, I got a positive number. The t-score is going to take the same value as the coefficient itself. It's going to be the coefficient divided by the standard error for the t-score. As I showed you earlier, the standard error is measured in absolute value terms, so that's not going to be an issue. And so it's not going to offer a sign of any sort. It's going to be the numerator. We got a positive number. I don't know. I didn't make up any t-scores. I'm not sure what the point would be. We can do some examples. What I want to do is live in a Zoom do some examples. But for this one right here, I'm not even going to give you any t-scores. I already know this failed. I already know I failed to reject the null hypothesis because it's going to be out here somewhere. It's going to be to the right of 0. So therefore, it can't possibly be in the range we want it to be, which is to the left of 1.706 if it's a positive number. Failed. This one might pass. We got the right sign. We got the right sign. We just need to hope that the t-score was bigger than 1.706. I mean, whether it was or not, we're making it up anyway, but that's going to be the problem. We'll be able to say it was significant. Now, if we got the right sign, but let's say the t-score was 1.5, we have to say, well, I got the right sign, but it wasn't significant, which is a big deal because it says, for all we know, that number could really be 0. All right? It really has no impact whatsoever on grade. When you can't reject the null hypothesis, it means you're saying, I don't even know if this really has an impact on this variable or not. I don't know. I don't have enough confidence to say. On the two-sided one, we don't care what the sign is. We just want to know, is it to the left of 2.056 or to the right of 2.056 over there? If it is, we reject the null hypothesis. If we don't, we haven't. Now, many economists, and we've had people come and present papers and stuff, and I've caught a number of people on this, and I don't like to criticize the people who have come to speak to us because I just think that's rude. But this criticism is helpful. I've seen people do this so often. They have done what should be a one-sided test. They've done it as a two-sided. And look at how much harder you're making life for yourself. On a one-sided test, you're only going to be bigger than 1.706. But with the same level of significance, on two-sided, it's going to be bigger than 2.056. So if you should have done a one-sided, but you did a two-sided, notice there's a range in there where it didn't pass here, but it did pass here. For example, what if it had been 1.8? What if the t-value you came up with was 1.8? You're like, well, crap, 1.8 is not significant. Yes, it is. If you hypothesized it was going to be a positive number, it was significant. And so you have to use the right test. You have to and you'll almost always be doing one of these two. It is extremely rare that we put in a variable that we don't really have a sense of whether it would be a positive or negative impact. Extremely rare. Almost every, and here's another problem. The computer, when it spits out the results for you, it will give you a critical t-value, but it's giving you that one. Because it doesn't know whether you meant positive or negative, right? It doesn't know what you hypothesized. So it just spits out the two-sided. So you're going to have to look it up on a table to figure out what the one-sided is, which we're almost always going to be doing this. And yet many people make the mistake of doing it this way, when in fact, ironically, it makes life more difficult for you. So a couple of times now, I was very proud, a couple of times I've been able to say, actually, I think your variable over there is significant, which is something you want to hear when you're presenting a paper, like, oh, you're right, that works out great for me. This book is so good about that, making sure that you're doing these tests properly. So, let's see. Anything else I'm going to tell you about here? Need to know degrees of freedom. Oh, yes. Big deal. This is only telling us the statistical significance. It is not telling us the importance. For example, what if the coefficient on hours had been 0.02? For every hour of study, you increase your grade by 0.02. That ain't a whole lot. So you're like, well, it's not really important. It's statistically significant. It turns out that, yeah, when you study an extra hour, you pretty much get an extra 0.02 added on to your 100-point exam. But it's not very important, right? Because the value here is what's going to give you the importance of it relative to this number on the far left. But it's only giving you statistical significance. This book was singled out, oh, I think I told you this earlier, by a famous critic of econometrics as saying, oh my God, this is like the only book that does that properly, right? So that tells you statistical significance but not importance. Oh, and then the rest of this chapter is on the F-test. I have never used an F-test in my life. And one of the great things about teaching is that you can pick out the stuff you find interesting and leave out the stuff you don't find interesting. Usually, sometimes you can't do that. I don't find the F-test very interesting, and I don't really see many cases where it would be useful. So I'm not going to go over it, and you're not going to be responsible for it. Okay, so that's it for chapter 5. I want to do a bunch of examples in the live Zoom stuff, but I just want to give you some basic background as a reference here. Thank you.